Alright, in this video I'm going to solve PQ19.2, and I'm going to use the circuit reduction method, where I'm going to reduce things into smaller parts and solve it in parts like that. So the first thing I'm going to do is I'm going to look at this 8 and the 9. First thing we do is we reduce this to a solvable circuit. So 8 and a 9, that's 17 ohms, right? And then this guy, the 17 and the 19 are in parallel, right? So that's going to be 1 divided by 1 divided by 17 plus 1 divided by 19, right? So I get my calculator and I go 17 to the minus 1 plus 19 to the minus 1 to the minus 1, right? So that's what I do with the calculator. Is I will just do with these ones with the minus 1. I'll just use that, and I'm going to store that in A. That's my A. A is 8.972 repeating ohms, right? Okay, and then I've got A and 4 and A and 5 and 6. These guys are in series. Okay, so that the answer to that's going to be 4 plus A, where A is 8.972, right, plus 5 plus 6. So 4 plus alpha A, which is just going to use that value there, right, plus 5 plus 6. I'm going to store that in B. So 4 plus 8 plus 5 plus 6. 23.972. So my B is 23.972 repeating. And then, you know, if you look at the bottom here, the bottom of the sheet, these values here, you can see we're kind of on the right track. This thing right here is me solving it using an Excel spreadsheet. Okay, so far we've got that, and now this guy, B and 13, are in parallel because their ends are connected here. Right, so we can circle that, and then the circuit's solvable now, right? So that's going to be 1 over 13 plus 1 over B, where B is this value here, right? Okay, so I'm going to go parentheses. What was that thing? 13 is the one, right? So 13 to the minus 1 plus alpha B to the minus 1. Minus 1. That's 1 over 13 plus 1 over B, right? And we got to store that in C. We're on C now, 8.429. And now we have a solvable series circuit. We've got a current that goes out here, right? Here it goes into this mess that we're going to call C, right? But this is a series circuit, and we can solve the series circuit. The series circuit is going to be the current, the one current is going to be 57 volts. That's my source voltage, right? Divided by 5 plus C plus 3, right? 5 plus C plus 3. So we're pretending this is all one resistor, right? So my one current is 57 divided by parentheses 5 plus C plus, what's the other one? 3. Okay, 3, and I'm going to store that in alpha D. Okay, so we've got the current is 3.469, I'll say 5 amps, right? And then now we can figure out that's going to be the reading on A1, right? Solve the answers to 3 sig figs. So the 3 sig figs is, we'd say 3.47, right? Right, that's going to be our reading on A1. Okay, and then V1 we can solve now. And V1 is very important because V1 is going to let us solve the rest of the circuit here. Okay? V1 is the voltage from there to there, and we can solve stuff like that. So to find V1, I'm going to use IR. IR, okay, and so it's going to be 3.4695. I'm actually going to use what did I call this? I call this D, right? Okay, times that resistance, which is 8.429, whatever, right? But really this is just going to be D times C, right? And of course I'm going to store that in, I guess, E, right? Okay. Okay. So alpha D, enter is that, right? And then alpha C is that, right? So alpha D times alpha C, store that in alpha E, right? That's 29.244 volts. That's V1. It's also what we stored in E. Right. So 29.2 with 3 sig figs, that'd be our voltage there, right? Okay. So now we can solve for some things. Since we know the voltage from here to here, the current through the 13 ohm is really simple. That current is going to be that voltage, 29.2, because that's the voltage from one end of the resistor to the other, right? Okay, divided by 13. Okay, so V2 is this 29.244 divided by 13, right? That's not V2, sorry, that's the current through the 13 ohm, right? Okay, so that is alpha E, which is this guy, right, divided by 13. And I don't think we need that, but that's 2.24955 amps, right? So that's, I guess, it's 2.25 amps. Okay. Right, and then, whoops, I keep writing it there. It's like, it's not the right place. I think I'm doing that, right? It's this guy here, right? 2.25 amps. Okay, and then the current through the 4 ohm, we can figure that out because that current, we know this voltage here, okay, the voltage right there, is across this thing here, right? So I could take that thing, the current through the 4 ohm, right, is going to be this voltage here, 29.244, divided by this entire resistance there, right, which is actually B, right? It's 4 plus 5 plus 6 plus this whole mess, right? So that's divided by okay, so let's see, this guy is E, alpha E, and then that guy is alpha B, yeah? Okay, so it is alpha E divided by alpha B, right? So I'm dividing this voltage here, which is E, by that thing there, right? And then I'm going to store that in F. That's 1.2199, right? So that's our current here. Let's see, I guess we should say 2 amps, right? And then I'm just looking at the bottom here. We are on track, right? We've got those numbers, right? Okay. Now we can find V2, okay? V2 right there, I can just do IR, right? The resistance is 4 ohms, and the current is 1.2199. We just figured that out, right? It's that current is going through the 4 ohm, right? Okay. So I can just set it up like that, and then we've got it's times 4, right? So that times 4 is 4.88, right? Finally I get to fill that one in. I've been wanting to fill that in, only now I've got the right thing there, right? Okay. Let's see, and then we can also find V3 right now, okay? V3 is crucially important because it's the voltage from here to here, and we're going to use it